All right, so the last video number 3, about doing integrals that either involve arctan or look like they might involve arctan. All right, so let's go ahead and do the integral of 1 over x squared plus 2x plus 2 dx. So this problem is a little bit of a doozy. We haven't done a lot of these in class, but believe it or not, this is in the AB curriculum. So how in God's name do you do this, right? If you were to go about doing a u sub, maybe you'd let u equal 2x squared plus 2x plus 2, but then du would be 2x plus 2, and you don't see that, right? You get too much function. So a u sub of letting u equal the denominator is not going to work here. It certainly doesn't look like x squared plus 1 or some stuff squared plus 1 on the bottom. So you're thinking, how could this even possibly be arctan? So it turns out that when you have a trinomial in the denominator like this, and you've exhausted all your other possibilities and nothing else is working, you don't recognize it, you can't use a calculator, u sub doesn't work, it turns out that completing the square on that denominator is a solid little move. So I'm going to kind of do that to the side here. So how do you complete the square? All right, this is going to be kind of a crash course on it. I'm not going to get too in depth, but the first thing that you want to do is kind of separate your variables and your constant. So now there's no equal sign to move things. So this is more like just for my own brain purposes that I separate the variables from the constant. The next thing that I have to make sure of is that my leading coefficient on my squared term is 1. And we get lucky here, it is 1. If it wasn't 1, I'd have to factor that value out just out of the x squared and the x term. I wouldn't want to factor it out of this, okay? I mean, I could, but I myself don't. So you're like, all right, so what do you do now? Well, what I'm going to do now, once I have those goals set, is I'm going to add I'll call it the magic number or the square number. And the magic number or the square number, if you remember, is always half of the b value squared. And the b value is whatever is attached to the x when you have a leading coefficient of 1 on the square term. So b is 2. So half of 2 is 1. And when I square that, I get 1. So now if you think about this, if I come back over here and rewrite what I've done, I have the integral of 1 over x squared plus 2x. I just went ahead and added 1 down there, right? And then I have this plus 2. Well, that's changing the problem. It's not like I multiplied the fraction by 1 over 1. I added 1 to the bottom. That changes it. You can't do that. So you have to figure out a way to undo that. And it's actually not too difficult. How do you undo adding 1? You're going to subtract 1. So I'm just going to do that. So now you'd all agree that if I combined all of this, I would get that. And you might be saying, well, why did you do it? Well, this is why. This guy right here, and I'll go back over here. This guy right here is now what we call a perfect square trinomial. We completed the square. This here, I could just go ahead and combine. 2 and minus 1 is going to be plus 1. Now, again, you might be saying, oh, you just add 1, you get the 2. I don't get what you're doing. Well, again, it's because this is a perfect square trinomial. What the heck does that mean? That means it can get factored as something quantity squared. So, all right, even if you forget what that means, let's just factor this. Let's factor this trinomial right here, right? So it's going to be a product of 2 binomials, and hopefully you see that x plus 1 times x plus 1 is what's going to work, because x times x is x squared. X times 1 is 1x. 1 times x is 1x. They will combine to 2x. 1 times 1 is 1, right? And oh, by the way, x plus 1 times x plus 1 is just x plus 1 squared. That's how I probably would have wrote it initially. And then you have plus 1. So you're like, all right, so let me go back over here now. Maybe you're starting to see it. I can rewrite this as the integral of 1 over now x plus 1 quantity squared plus 1. Okay? That's kind of neat, right? You should agree. If I multiply this out and add the 1, I'm still going to get this original problem. So all I have done is using algebra, I rewrote this integral. Now, why? What was the point of doing all this? Because now look at what I have. I have 1 over stuff squared plus 1. And by the way, stuff is linear stuff. So that means a nice little U sub, or maybe a U sub in my head, a little reverse chain rule is going to work here. All right. So if you don't know what I'm talking about reverse chain rule, first off, reverse chain rule doesn't exist, but there is a little shortcut you can do when your U would be linear. Watch the first video. It'll go over it. Right? Do I know a function whose derivative is 1 over stuff squared plus 1? I do. It's going to be arc tangent of stuff times 1 over the derivative of stuff. Stuff is x plus 1. The derivative of that is 1. Don't forget my constant of integration. All right. Obviously, 1 over 1 is just 1. So I get arc tangent of x plus 1 plus c. So at first glance, when you looked at this, you're like, there's no way that's arctangent. And then you do this little thing called completing the square, and goodness gracious, it turned into the form, the structure, 1 over stuff squared plus 1. All right? So those are 3 videos, all involving integrals that either involve arctan or look like they involve arctan. I think it would benefit you big time to go over it, to practice them, to try it for your 2-question test, which is coming up in a few weeks. All right? Hope all is good. Be good.